We can continue, children. The next problem is for the matrix A, 3 by 3 matrix, 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. Show that a cube minus 6a square plus 5a plus 11i is equal to 0. Hence, find A inverse. So, using this equation, you have to find A inverse. So, first you have to prove this. This is equal to a 0 matrix. So, first we can find a cube. So, a cube is a square into a. So, first we can find a square. A square is equal to a into a. That is matrix 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3 into the next matrix A itself 1 into 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. Then multiply this. So, we get a 3 by 3 matrix 1 into 1 plus 1 into 1 plus 1 into 2, that is 4. 1 into 1 is 1, 1 plus 2 is 3, 3 minus 1 is 2. The next element 1 into 1 minus 3 plus 3. So, that is equal to 1. The next row 1 into 1, 1, 1 plus 2 is 3, 3 minus 6 is minus 3. Then 1 into 1, 2 into 2, that is 4 plus 1, 5, 5 plus 3 is 8. The next element 1 into 1 minus 6, then minus 9. So, minus 15 plus 1 is minus 14. The next row 2 into 1 is 2 minus 1 plus 6. So, 8 minus 1 is 7. 2 into 1 minus 1 into 2 cancelled. So, minus 3. Now, last element 2 into 1 2 plus 3 plus 9. So, that is 14. So, that is equal to a square. Now, we have to find a cube. A cube is equal to a square into a, or you can write a into a square. So, a square is 4, 2, 1, minus 3, 8, minus 14, 7 minus 3, 14 into a. Okay, you can multiply. So, 4 into multiplication is first row into first column, then in between you have to put plus sign. So, 4 into 1 is 4, plus 2 into 1 is 2, plus 1 into 2, that is 8. The next one is 4 into 1 4, plus 4, that is 4 plus 4 8, 8 minus 1 is 7. The last one 4 minus 6, that is minus 2, plus 3. So, that is equal to 1. Now, the next row minus 3 into 1, that is equal to minus 3, minus 3, then we have 8 into 1, then minus 14 into 2. So, 8 minus 28 is minus 20, so minus 23. The next element minus 3 into 1 is minus 3 plus 16 plus 40. 16 and 40 becomes 30, 30 minus 3 is 27. Then minus 3 into 1 minus 3, minus 24, then minus 42. So, minus 42, that is minus 66, and 3 is minus 69. Now, the next row 7 into 1 minus 3 plus 28. 28 plus 7 is 35, so 32. Then 7 minus 6 minus 14, this becomes minus 20, plus 7 is minus 13. Then 7 plus 9 plus 42. 42 plus 9 is equal to 51, that is 58. So, 32 minus 13, 58. Now, the next term is 6a square. So, multiply a square by the scalar 6. A square is 4, 2, 1, minus 3, 8, minus 14, 7, minus 3, 14. So that's equal to 24. Scalar multiplication is multiply each element by the number 6. 4 into 6, then 2 into 6, 1 into 6. Next row, 6 into minus 3 minus 18, 6 into 8 is 48, 14 into 6 is 14 into 6, that is 84. Now the last row, 6 into 7, that is 42, minus 18, then 84. Now the third term is 5a. 5a is equal to 5 into a. A is, that is 5 into matrix 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. So that is 5, 5, 5, 5, 10, minus 15, 10, minus 5, 15. Then the last term is 11i. 11i is equal to 11 into 3 by 3 matrix 0, 0, 0, 1. That's equal to 11, 0, 0, 0, 11, 0, 0, 0, 11. Now find what is a cube minus 6a square plus 11i, sorry 5a plus 11i. What is the value of that? Okay. So a cube, 8 minus 24, 8 minus 24 is equal to minus 16, minus 16 plus 5 plus 11, that is 0. Next element, 7 minus 12 is minus 5, minus 5 plus 5 is 0, 0 plus 0 is 0. 1 minus 6 is minus 5, minus 5 plus 5 is 0, plus 0, 0. Next row, minus 23 plus 18, that is minus 5, plus 5 is 0, 0. 27 minus 48, 27 minus 48 plus 10 plus 11. 27 plus 10 is 37, 37 plus 11 is 48, 48 minus 48 is 0. Then minus 69 plus 84 minus 15, 69 and 15, that is minus 84 plus 84 is 0. Last row, 32 minus 42 plus 10 plus 0, that is 0. Then minus 13 plus 18 minus 5, that is 0. Then last element, 58 minus 84 plus 15 plus 11. So 58 plus 26 minus 84, that's equal to 0. So this is equal to a 0 matrix. So we proved. Now from this equation you have to find A inverse. So in the last chapter we studied how to find inverse by using elementary transformation, and in this chapter in the last section A inverse is equal to adjoint of A by determinant A, that also we learned. Now this is another method. If one equation is given, from that we can find inverse of this matrix. So how to find inverse? So equation is 11i is equal to 0. Pre-multiplying this equation by A inverse. Both sides you have to multiply by A inverse. A inverse into 0. So this is 0. Left hand side A inverse into A cube. Multiply. Multiply like this. A inverse into A cube. The power you have to. A inverse into A cube means A raised to minus 1 plus 3. That's equal to A square. That way you have to write So a square minus 6 into a inverse into a square becomes a, then 5, a into a inverse, so a raised to 0. So that we can write as a raised to 0 plus next is 11 into I into a inverse. Right hand side is 0. Now a square minus 6a. Here it is 5 itself. So for metric simplification we need to write 5 as a matrix. So we can write 5i plus 11 into a matrix into identity matrix is that matrix itself. So a inverse. So 11a inverse is equal to, take other terms to the right hand side, 6a minus a square minus 5i. Now give the value of a. A means the matrix 1 1 1, 1 2 minus 3, and the last row is 2 minus 1 3, and minus a square. What is a square? A square is equal to 4 2 1, 3 minus 3 8 minus 14, 7 minus 3 14. Now minus 5i, that is minus 500 050. Now simplify this. So 11a inverse is equal to 6 into 1 minus 4, that is 2, 2 minus 5 is minus 3. Next element 6 minus 2, that is 4, then 6 minus 1 is 5, then 6 plus 3 is 9, 6 into 2 12, 12 minus 8 is 4, 4 minus 5 is minus 1, minus 18 plus 14, that is minus 4, then 6 into 2 minus 7 is 5, minus 6 plus 3 is minus 3, 18 minus 14 is 4, 4 plus 5 is 9. So minus 3, 4, 5, 9 minus 1 minus 4, 5 minus 3, then 18 minus 14 minus 5. It's equal to, the last element is minus 1. Here it is 4. So that is 11a inverse. So what is a inverse? A inverse is equal to 1 by 11 of minus 3, 4, 5, 9 minus 1 minus 4, 5 minus 3 minus 1. So that is a inverse. Now the next question. Question number 5. For the matrix A, 3, 2, 1, 1, find the numbers A and B. Find the numbers A and B such that A square plus A into A plus BI is equal to 0. We have to find small a and small b such that a square plus AA plus BI is equal to 0. A is given. So first we find a square, 3, 2, 1, 1 into 3, 2, 1, 1, multiply 3 into 3 9, 9 plus 2 is 11, 3 into 2 6 plus 2 is 8, 1 into 3 plus 1 into 1 is 4, 1 into 2 plus 1 into 1, that is 3. Now A into A, what is A into A? Multiply matrix A by small letter a. So that is 3A, 2A, A. Then we have BI. Bi means B0, 0B. Here we take I as 2 by 2 matrix. Now A square plus AA plus BI is equal to 0 implies. So all these are 2 by 2 matrices. So just add everything is addition, add the corresponding elements. So 11 plus 3A plus B is the first element. Next element is 8 plus 2A plus 0. Then next row 4 plus A plus 0. Then 3 plus A plus B is equal to 0, means 0 matrix. So write as a 2 by 2 matrix. Now for finding A and B, equating corresponding elements. So we can equate this one. 4 plus A plus 0 is equal to 0, means A is equal to minus 4. Now the last one, 3 plus A plus B is equal to 0. A is minus 4. So what is B? So A is minus 4 and B is equal to minus 1. Now one more question. Question number 6. If A is an invertible matrix, if A is an invertible matrix of order 2, if A is an invertible matrix of order 2, then what is determinant? Determinant A inverse. What is the value of that? So look, A is an invertible matrix. The definition of invertible matrix, if A is an invertible matrix means there exists another matrix B such that AB is equal to BA is equal to I. Then we say this B as the inverse of A. Or another way we can write, if A be an invertible matrix, then there exists its inverse. Let A inverse be the inverse of A such that A into A inverse is equal to A inverse into A is equal to I, where I is an identity matrix. So we can take A into A inverse is equal to I. Now determinant A into A inverse is equal to determinant of I. These all we discussed in the previous videos. So determinant A into A inverse is same as determinant A into determinant A inverse. Do you remember? Then what is the determinant of an identity matrix? That is 1. So what is determinant of A inverse? Determinant of A inverse is equal to 1 by this determinant A. It's a number. So determinant A inverse is equal to 1 by determinant A. So determinant A inverse, another notation is like this. So that's equal to 1 by determinant A, or you can use like this. Okay. So if A is an invertible matrix of order 2, then what is determinant A inverse? Determinant A inverse is equal to 1 by determinant A. Okay. So I hope all of you understood this section. Thank you.